Hello, I'm Stefan Graeber, project leader for LXD, and today I'm going to be looking into a pretty advanced networking topic. That's LXD and its integration with BGP. BGP is the Border Gateway Protocol, which is a protocol that internet routers talk to exchange route with each other. That effectively makes the entirety of the internet as we know it. Each router communicates with others to announce what their routes are, what routes they learn from whom, and then they can each figure out what the best path is for any given packet. It's these days also used not just at the edge on routers, but also now internally more and more for servers to be able to announce their own specific routes for, in this case, effectively cloud instances. It's a pretty old protocol, but supports a lot of, there's quite a lot of extensions, has some amount of security features here and there. But for what we're looking at today, we're not going to be doing too much of the kind of fancy root authentication and filtering and all of that kind of stuff, which is quite a bit more advanced BGP config. Really the focus here is to look at what LXD supports as far as integrating with BGP routers. So first, maybe why would you even want to do that? So in a previous video on ingress, I showed that one nice thing you can do if you just want your LXD to kind of work is just announce, like add a static route to your home routers for the subnet that LXD is hosting, and then all of your machines on your network will magically be able to talk to those instances and everything just works. That doesn't scale super well when you're dealing with hundreds of thousands of servers that each have their own networks. If you need to ask your network admin for every one of them to go and add a static route, that gets annoying pretty quickly. It's also not super practical when you're trying to have more granularity than the entire network. If you just want to route a single IP address to an instance on a specific machine, it's not very practical to go and put static routes for that. Instead, what you can have is effectively LXD telling your upstream, your router, what it needs routed to it. And that's what we use BGP for. So LXD effectively has a small built-in BGP server. It can connect, in BGP parlance, it would be peering. So it can pair with a router and it will then announce whatever routes it has. It will also receive routes from the router, but those are just completely ignored. LXD doesn't do any kind of local network config or anything based on BGP. It's really just announcing stuff over it. All right. Let's take a look at how that all works. So switching here, I've got one system, in this case an Intel NUC. This is running LXD 5.0. It's got a single instance running. It's called U1. It's currently got kind of the box standard config where it's just LXD in it with all the defaults. So I've got a local network, LXD BR0 here. It's NATed, nothing special. The instance has a private IPv4 address, private IPv6 address. It can talk to the outside world over both IPv4 and IPv6 through NAT. That's it. There's really nothing special. I do have a router here, which is one of my main routers at home, which does run BGP. So you can look at the BGP summary, it shows all the peers I've got. Got a fair amount. It manages both IPv4 connectivity and IPv6 connectivity. It peers, those are already like my production LXD servers, effectively, production LXD cluster, actually. Then it peers with upstream routers of IPv4 here, of IPv6 here. And it peers with a one NAS server, which is actually my desktop machine because I use LXD BGP on that one too. And here we can, there are columns that show the number of prefixes that were received and that are announced. So for anything that's LXD, it's not announcing anything because there's no point. But it is announcing prefixes, in this case for IPv4, to the upstream internet routers here, and same thing for IPv6. But we can see that it is receiving a number of prefixes here over, well, from the LXD cluster, and same thing for IPv4, it's receiving a number of them here. So that's a BGP router. In this case, it's running actually on Linux. It's FRR, which is a software routing suite that exists. Open source, all really nice and fun to use. It mostly lines up with the Cisco iOS type syntax. So if you're used to configuring, corporate switches and routers and stuff, that won't feel too foreign for the little bit I'm gonna be showing. The LXD side is always identical, regardless of what kind of router you might be talking to, but just, yeah, the router side of it will vary based on vendors. Okay, so let's look at the LXD side of things. The first thing we're gonna want is to set up a BGP session between LXD and the router. So it's effectively setting up the peering between the two. For that, we need to configure both sides with addresses, a BGP autonomous system number, and a router ID. So let's go and do that. On the NUC side, I'm going to be enabling the built-in BGP server in LXD by doing LXD config set, and then there's 3 config keys that must be set. There is the BGP address, which is what address to listen for BGP traffic on. I'm just gonna use :179, which just means all addresses on port 179. That's the default for BGP. Then I should do the ASN, so that's the autonomous system number. If you are running public internet services, you will have usually will have your own of those. If it's for internal testing example type stuff like we're doing here, you can use an internal one of the reserved internal IDs. So in this case, I'm going to use 65,100. And lastly, you need to set the router ID. This doesn't matter too much, other than it must be unique amongst all the peers of your BGP setup. And it's because I'm just going to be using 10.0.0.2. Okay, so that should enable the built-in BGP server in LXD, but it currently doesn't know where to connect to, so it's just listening. That's all it does. Let's see if we can find it. Yeah, we can see it's now listening on port 179, but it doesn't connect to anything at this point. The next thing is to configure LXD network. So in this case, our instances are on XDBR0, so that's what we're going to be configuring. So you need to configure that network with informations for its peers. So let's see network set LXDBR0, which is our bridge, and then 2 config keys. The first one is the IP address of the router. So you need to give it a name here. It's called FW101, but you can call it whatever you want. The name doesn't matter other than it must be used for the config keys. Its IP address in this case is this. I'm going to be using IPv6 for peering in this case, mostly because it's got the nice advantage of being able to announce routes for both IPv4 and IPv6 over one session. So that just makes it slightly simpler. But if you only have IPv4, use an IPv4 address here. That works just the same. So I set that address, and then I also need to set what the ASN is of the router I'm talking to. In this case, it's this, which is my own ASN. I've got an allocation and everything on the internet, so that's my own ASN. But if you're just doing a test environment, something, there's going to be another 65,000 something AS that you would have configured on your router. So as far as LXD is concerned, that's all that you need to do. At this point, LXD will be trying to connect to that router, will be trying to set up a session. The router itself hasn't been configured yet, so that's not going to be very successful, but we can actually start looking at the log. Yeah, so it does show the peer configuration, but doesn't show that it's configured, that it's up yet. Okay, let's go look at the router now. So I'm going to be entering configuration mode on the router. Again, anyone who's going to use the Cisco type CLI will recognize that. If you're using a completely different vendor, it might work completely differently. But I need to go into the config for my router. So that's router BGP and then the ES number of the router. And I need to add a neighbor. So then I need to put the IP address of my LXD server. I'm just copy pasting it there. And remote AS, and then the AS number of the peer. So in this case, LXD, we used 65,100 before. Okay, so that's the basics as far as describing both peers. but now there's no configuration that actually allows for any routes to be exchanged yet. So next step is to do address family, IPv4 unicast. So that says that we were gonna want an IPv4 session with that. And there's a few lines to do. So the first is gonna be allow software configuration for inbound sessions that allows effectively changes of prefixes and configuration without needing to completely tear apart and reestablish. That's pretty standard. The next thing is BGP these days. Like most BGP servers these days require that prefix filters be put in place for everything you receive and that you push out. That's mostly to avoid accidentally propagating stuff across your network by having misconfiguration. In this case, I'm doing something you shouldn't actually be doing, which is using a prefix list that allows everything. So effectively just bypassing the check. Then for the filter for outgoing, I'm setting a filter that filters everything because again, LXD doesn't care. LXD doesn't actually do anything with what it receives, so we might as well not send it anything. So that just prevents any routes from being sent to LXD itself, and then we need to activate it. So that's IPv4 done, but we also care about IPv6. So let's do the same for IPv6. And so exactly the same thing, inbound, the prefix list for inbound, prefix list for outbound, and activate. Okay, so the config is done. Now, if we look at the LXD side of things, there was some activity. It tried to come up, but then failed because the family was not allowed, and that disconnected it. But now it's up. And on the router side, we can just go to a BGP summary, which now shows our new peer here. It's been up for 8 seconds. It shows that we are not receiving anything, not sending anything for IPv4, not receiving anything, not sending anything for IPv6. But the session is established and it's all up and running. All right, so now let's do something with that. Going back to LXD. The first thing I'll do is I've got IPv6 allocation, so I can actually give a public IPv6 subnet that will be announced through BGP. So let's try and do that. As I said, my current network here is a normal, completely normal LXD BR0. As we can see, we've got a random IPv6 site local address with NAT enabled. But we can change that now. So if I go and I change that address on IPv6 to what's gonna make it? So my home subnet is this, and then let's do EF is not used. So set that as a subnet and not enable NAT. Yeah, that will work better if I put the name of the network. Okay, so if we look at the config for the network, it has changed just those 2 keys. And if I look at my instances, they are probably a bit confused, so let's just bounce it. Okay, and now we've got the public IPv6 address here. Just for fun, let's switch to my desktop machine, which is nowhere near that NUC, and ping that IP address. And that works. If we do an MTR to see where it goes, we see it actually jumping around a fair bit before it reaches the right server. So that got announced properly. Like in this case, it's going from my gateway to an upstream router to the router that we're peering with, to the LXD host, and onto the actual instance. And now looking at the, whoops, disconnected. Looking at the router, we can see still over IPv4, nothing, 0 received, 0 sent, but over IPv6, we've received 1. And you can actually go and ask for exactly what did we receive by doing show BGP neighbor, then the neighbor, and do received routes. And you can see that LXD has announced that subnet with itself as the next hop for the route. So that's pretty neat. That's working great for IPv6. But now say you've got some amount of IPv4. You probably don't want to waste it all on one network by giving a /24. That would be incredibly wasteful. But what about just routing a single IP address to an instance? Well, we can totally do that. So say we've got that instance U1, and we want to give it an unused IPv4 address that's ion. So we're going to be doing lexi config device override u1 eth0, and going to be adding the config key IPv4 root external, and then the IPv4 address that we want. Just to prove that this is currently not headed anywhere, let's just switch. So it's 45.45.148.230, 45.45.148.230. That currently says hosts unreachable because it's an unused address. Now we're just gonna push it there. Device is overridden. Let's go look in the router, and if I do the summary, now IPv4, we see there's one here. And if we want to, if we go ask what that neighbor has for us of IPv4, you can see that one IP address. Next up is the IPv6 address, which is the nice thing with just using IPv6 for BGP peering sessions. We can totally do that and don't need to have 2 sessions. And if I go here, we can see that now it doesn't say host unreachable, but it still doesn't do anything. Actually, it does say host unreachable eventually, but it's being responded. That's LXD itself that's sending us that. The reason for that is simply that the instance doesn't actually use the address yet. If we look at U1, it still doesn't have it. So let's just temporarily add it to the instance. So address add 45.45.148.230, set 32, and let's just shove it onto the loopback device of the instance. Oh, it doesn't show loopback, right? So that's fine, and 9 pings. And we can do the same thing with IPv6 if we wanted. You can even route larger chunks if you want. So in this case, say we go and edit U1, go look at its snake. There's that IPv4 address we're routing. But what about, say, we route it? So EF is what we're using on the host, but let's use EFFF/64. So that will route an entire /64 IPv6 and straight to that instance. So saved. Go look at what the router is doing. Oops, BGP summary. Yeah, so we're up to 2 IPv6 subnets being routed now. And if we go look at IPv6 received subnets, you can see that we've got EFEF, which is the subnet used for the network itself, and then we've got EFFF that's also routed through the same host, and that goes into that instance. Similarly to earlier, if I just ping that subnet, so it's EFFF and say the first address of it, that's not gonna be doing much good. Oops, also because it's wrong. But okay, it's going nowhere. Same deal, I would need to actually start making use of it in the instance, and things will work a lot better. EFFF. Okay. The other right, EFFF one on your back. Yeah, that should be right. This is slightly puzzling. What did I mess up? Okay. Okay, it's headed to the right thing. Oh, it doesn't. All right, we're gonna need proxy and DP, I believe. So it's just because we're dealing with an entire subnet. Conf 0. Is that what we need? Does that make it work better? Not quite. Okay, just checking that it works from within the instance at least. It does. Okay. I wonder if it works better if I add that in IP address to the loopback instead. Address down. Okay. What did I mess up? PH. Okay. Oh, I added it as a /128. All right. Okay. So let's just add it as a 64 onto the NIC itself. Here we go. Okay. So it's slightly more involved to get the traffic flowing than a single IPv4 address. There's always a bit of differences here. But yeah, now that works properly. So the LXD side was perfectly fine. The traffic was actually headed to the instance, but the instance was not actually responding for the NDP, which is the ARP equivalent on IPv6. So with that in place, now it's working perfectly fine. And that's pretty much it. So right now we've got a setup where the network has a public IPv6 subnet that's exposed. It's using a private IPv4 subnet, but has a public IPv4 address routed to a single instance and has also an entire IPv6 subnet routed to the instance as well. This is pretty interesting because, you know, if you're running a LXD cluster, for example, you would have such BGP sessions with every one of your cluster members. That's in fact exactly what I have in my deployment here. As I said, like all of those are LXD servers running inside of a cluster. And now if you move an instance between those, any kind of routes that it has, like any one of those external routes will just stop being announced from the machine that it's on, be announced by the new machine. And you don't need to reconfigure anything. You can move things around and the routes will just move around. That's really quite flexible. There's also a lot more you can do if you're using Oven with LXD, because if you do, then within a cluster, each one of the, like you're gonna have, your network is gonna span multiple servers. LXD will announce routes that are instance specific from the machine that the instance runs on. The reason why it does that in the deployment is, in such deployments, is so if that machine goes down for some reason, it loses power, something bad happens, then that route will time out and go away without like will go away and come back when the system comes back, instead of lingering and sending traffic somewhere that doesn't exist. But routes that span multiple machines, so like your routes for a network, for example, those will be announced from every single one of the machines within the cluster, which then makes it just more robust. The other thing that's worth keeping in mind for, well, that's actually kind of done reasonably well, LXD does need to restart occasionally, especially when it gets refreshed, and that means the LXD daemon will go away. When that happens, you don't want all of those routes to just disappear, because that would be pretty crappy. Like you just see a network cut effectively from all of your clients temporarily for a few seconds while LXD is restarting. So instead, LXD uses a BGP extension, which allows for a like a clean shutdown. So it will tell its peers that I'm restarting now. This is a graceful restart. It's normal to not hear from me for the next 5 minutes. Just keep the routes as they are. And the routes will only time out and get removed by the upstream routers if LXD doesn't come back after that 5 minutes delay. So that allows for effectively completely seamless restarts of LXDs and everything without pulling any of the routes. And that's it. I don't really know how many people this will be useful to. It is pretty advanced networking for sure. But I mean, as I'm doing here with my own routers, they're all open source based using FRR. They will run inside of some LXD containers, so you can definitely experiment with it. You can definitely play with it, and maybe, you know, one day be in an environment where you can actually use that on the public internet, which then makes it really, really cool. All right. Well, thanks for watching. If you've got any questions, you can leave them down below. We do have a new documentation page on BGP that will be linked there too. That's the one I was showing at the beginning. And yeah, thanks for watching. See you in the next one. Bye.